Hey, this is Judah Anthony from Codecademy. In this walkthrough, I'm going to guide you through the project Lens Slice. We're going to be applying your Python skills specifically when it comes to lists. And if you wait to the end, I have some pro tips that are sure to up your game. When you're ready to code along with me, or if you want to check out any of our other projects, take a look at the Project Hub. I will keep the link in the description. Let's get coding. So we have Lenny's Slice. This is, as I have already talked about, this is a project to help us kind of dig into Python arrays, lists, and slices. So let's begin. I've already kind of opened it up here, but let me read the intro. You work at Lenny's Slice, a new pizza joint in the neighborhood. You are going to use your knowledge of Python lists to organize some of your sales data. So for the very first item in this project is to keep track of the kinds of pizza you sell. Create a list called toppings that holds the following. So we need a variable named toppings. Let's see if I can copy that because I never trust my spelling. And then a list uses square brackets in Python. And we're going to create a really long list. So I'm going to actually go ahead and break that on to multiple lines. And here are the toppings. Again, I am terrible at misspelling things. So when I have long lists of things like this, I will just copy and paste. In lists, these are all strings, so quote marks works perfectly well, but in lists you have to delimit them with a comma. Also on multi-line arrays, I actually like to have the comma on each line. This helps prevent errors if, for example, we decided to add a new jalapeno. If there wasn't a comma here, there would be a syntax error. So I just put commas on all of them. So let's see if we got any syntax errors. So far, so good. So let's check that off. And now to keep track of how much each kind of pizza slice costs, create a list called prices that holds the following integer values. So the first list array held strings for the toppings. This one is going to hold integers, kind of proving out that you can store all kinds of types. These are going to be a lot smaller, so I am going to copy and paste, but I'm going to just lay these all out onto a single line. Let's speed this up slightly. All right, so now we have toppings and prices. Next up, your boss wants you to do some research on $2 slices. Count the number of occurrences of 2 in the prices list and store the result in a variable called num $2 slices. Print it out. Okay, so let's just do a simple for loop here. We know we need the number of slices here, so we could just kind of initialize this with 0. And then we're going to do a for loop for each price. And essentially we're looking when the price equals 2. So if price equals 2, then we are going to, we want one more than the existing price. So if we take that variable and then we add 1 to it and store it back into the variable, then we should get the final amount. And we have to print this out. So let's see if we print. FYI, one of the cool things about having this kind of like online environment is it can build and execute and give all the outputs for you. Pro tip, a command enter will allow you to execute the kind of current workspace. So 3, let's see if that was right. We have 1 here, 1 here, and 1 at the end there. So 3 seems right. We're gonna call that done. Next up, we're gonna find the length of toppings, list and store that into a variable called num toppings. We could do a very similar thing where we instantiate num pizzas as 0. We iterate over each of the toppings and then basically count, add 1 each time. But we don't have to do that. We kind of get that for free with Python. So what we can do is, let's just get that variable name. There is a built-in method called length. And if you plug that into, we're looking for toppings here. That will give you the number of toppings. They don't ask us to print it because we are going to use it in the next item here. So print this string, we sell num toppings, different kinds of pizzas. And then we're going to use our new variable. Great, wonderful. Let's grab that string. We are going to print it. And because it's going to be a string, I'm going to have quote marks. So one of the cool things about the print method or print function is that it will print space delimited any of the items in any of the arguments. So what we could just do is turn these into separate arguments. Oops. So we have a string that says we sell, number of pizzas, different kinds of toppings. So when we execute that, oh, did I kill my other print statement? I guess I did. Whoops. Well, we'll just go from here. We sell 7 different kinds of pizzas. So let's see if that's right. We have 1, 2, 3, 4, 5, 6, 7. Looks right to me. We can check that off. Next up, we have used the existing data about the pizza toppings and prices to create a new 2-dimensional list called pizza and prices. Each sublist in pizzas and prices should have 1 pizza topping and associated price. So it gives us it all laid out here for the data, but it also gives us an example. For this new list, make sure the prices come before the toppings, named like so. So this is the kind of format for each of these items. And it does have a note here. You don't have to use the original variables, toppings and prices, lists in this exercise. Create a new 2-dimensional list from scratch. So we are going to start with a list. It's definitely going to be big, so I'm going to break it onto 2 lines. And for now, I think I can probably just copy this. And we can start here. So let's, if you have an item selected and you type the kind of open bracket for the array, it'll kind of wrap the whole item. So I'm gonna just do that for each of these there for now. And then we need to, again, every item in a list is delimited by a comma. So it doesn't have us printing it out in this, but in the next one, it has us printing out our variable. So it's a two-dimensional array. So there is 7 items, and in the first element in each of those items, because there are subarrays in each one, is the price. And the second one is the topping or the type of pizza. So that looks about right. We're going to move into the sorting and slicing pizzas. So sort pizzas and prices variable array so that the pizzas are in the order of increasing prices. So this is a little tricky. I know there is a sort method. I'm not totally confident if that will sort subarrays properly, but why don't we try it? So let's see if we sort this. It looks like 1, 2, 2, 2, 3, 6, 7. That does seem to work. In this, there's also, I think, reverse. So if we wanted it in descending order, we could go in descending order, but the default, which is ascending order, is actually exactly what we want. So why don't we leave it at that? Slightly mistrustful of it, but let's leave it at that and move on to the next one. So first, we're going to store the first element into prices. So Python is a zero-based array system. So that means, whoops, that is the wrong variable. First element of that into cheapest pizza. So because it is a zero-based indexing system, the first element actually is going to reside at 0. So I'm going to just go ahead and print that, make sure I am getting what I want. Great, wonderful. So you see here the first item, which is the $1 pizza, is a cheese pizza. So I'm going to go there. Let's clean this up a little. And then the next item, a man walks into the pizza store and shouts, "I will have your most expensive pizza." I need to get the last item, which is going to be the most expensive pizza, and store it in a variable called priciest pizza. As we talked about, we know the last item is going to be the most expensive. We have this sort function. We could reverse the sort and just grab the first variable, but we also know we have this length function, which I demonstrated up here. So a kind of cool thing you can do is we know that the index of the last element is going to be the length, the array, but because it is zero-based, the fifth item is actually going to be 4. So we're going to minus 1 to that. So you can see that is the first one and the last one. I'm going to keep this one just so that we can keep track. All right, so it looks like the most expensive pizza from the previous step was anchovies. That is right, anchovies. Remove it from our pizza and prices list since the man bought the last pizza. So there are multiple ways you can remove, but one of the most simplest way to remove is to pop. Now, pop, if if it's given no arguments, will always pop off the end of a list. So theoretically, this should give us, let's copy this again. Great. So you can see here the last item here is 6 pineapple, and that is because the 7 anchovies was removed. So we know that worked out well. So we can, that actually is a good indicator of the state. I'm going to keep that one. And the next one is, since there is no longer an anchovies pizza, we want to add a new topping called peppers to keep the customers excited about the new topping. Here is what your new topping should look like. So it looks like it is a $2.50 peppers pizza. Add the new peppers pizza topping to our list. So we could append it to the list. However, always read the notes. The notes say, make sure to position it relative to the rest of the sorted data in pizza and prices. Otherwise, our data will not be correctly sorted anymore. So you can see here, we have $1, $2, $2, $2, $3, $6. So we actually want it to be inserted, not into the front, not into the back, but somewhere into the middle. So for that kind of insert statement, we can use the, let's just copy both of these. We can use the insert method. So where do we insert it? Well, this is, the first one is 0. So 0, 1, 2, 3. So we really want to insert it at the 4th item, and that will push 4 on back. So let's see if we can get that right. So we have 4, and then we know we want an array with 2.5 and peppers. So this looks like our reference. This is our new topping. Let's try that out. So we have cheese, mushrooms, olives, pepperoni, and then at 2.5 is peppers and then sausages. That looks just as I had hoped. So we will call that one done. 3 mice walk into the store. They don't have much money, they're mice, but they do want different pizzas. So take a slice of pizza and prices list and store it, the 3 lowest cost pizzas, into a list called 3 cheapest. All right, so this is where it gets fun and interesting. Slices are very similar to indexes. So you know how if you wanted to take the first item, you would just do first. If you wanted to take the 3rd item, you would do a 2. But what if you want to do 0 through 2? Well, you can just do 0:2. And that will give you the, let's go ahead and make sure we got this right. 2, again, represents the 3rd, though I'm not quite sure if that's inclusive or exclusive. So let's check that out. So you can see that's only 2, so that must be exclusive. So this actually needs to be 3. So it goes 2, but not including. Perfect. So that is the cheapest 3 elements in the array. Now, one of the cool things is we always like to save on typing. If it is 0 or the end, you can just omit it altogether. So you can, that is the same thing. Great job. The mice are very pleased to have you, and will leave you a 5-star review. Print the 3 cheapest list, which we have done actually. So we are technically complete. That being said, one of the things I like to do is after I write code, I like to read over the code and see how I could have done it better or more concisely. So why don't we read back over some of this? So we have 2 instantiated arrays. Those look pretty straightforward. And then we are counting the number of 2 slices. So I know, for example, if you know more of the syntax of Python, it can make things a little more elegant, a little more concise. So instead of this type of thing where you're incrementing a variable, happens very often. And because it does, there's actually a kind of shorthand for this. So if you want to add 1 to a variable and then assign it back to the variable, you can use this. So let me, let's see, let's open that back up and let's comment this out. Great, so that was 7, it remains 7. So that is a slightly more concise way, and honestly for me, more readable way of expressing that same thing. While we're here, this is totally doable. It is completely an accurate way of interleaving variables and constants, but we can also use a formatted string, which makes it slightly, arguably more readable. So we have the variable that is going to be in. So as you can see here, it's the same thing. Basically, the F means this is a kind of format string, and it allows anything in these curly brackets to be interpolated or basically executed and inserted into the string. So this num pizzas basically becomes 7. So that is another way of kind of embedding variables into strings. Let's uncomment this. Actually, let me just uncomment the rest of this. So we have a new variable. We have sorting. That looks pretty straightforward. This was one of the things. So this is a very kind of long and awkward way of indexing into the last element. And again, grabbing things at the beginning and grabbing things at the end happens very frequently. So what you probably want to do is something a little more concise. Because array indexes are only positive, because you're only going from the first to the second to the third to the fourth. In Python, if you use a negative number, it actually assumes you are indexing from the back. So if I nix this length and just keep it as -1, this is the same thing. So let me uncomment those. That should be about right. I uncommented too many things. Let's clean this up a bit. All right, that makes more sense. All right, so the first one, as we talked about, is the cheapest, but that -1 is anchovies. If I had done, for example, -2, this would be the second from last one, which happens to be pineapple. But of course, we want the last one, which is -1. So that is, again, shorthand way of kind of indexing into the back of a list or an array. Let me see. We have the pop. We have this. Oh, the insert. That is a good point. So we happen to know that the where this new item needs to go is at the 4th item. But having these kind of hard-coded magic numbers can be very problematic in a code base that you have to maintain over time. So for example, if someone added a new cheaper option here, all of a sudden that would change from 4 to 5. And so this would break and we wouldn't even know that it broke. So one way of doing this is to actually kind of dynamically look up item, what index should we use to insert? And so we're gonna have to write a little bit of code here to figure out which one is worth it. So think about this in the longhand. So let's say, well, let's just call this, let's iterate over each item. So we know we need to iterate over these. And we're gonna grab the index because that's what we need to store. So if we're gonna grab the index, we need to range of length. Now, I'm going to keep this up here. So this is like the new topping. So we can reference it inside our array, our loop. So we're going to iterate over each item, and each item will look similar to this, where the first item is the price. So it's already kind of sorted cheapest to most expensive. So essentially we need to get to the point where whatever we're looking at, the kind of pizza that is current, is more expensive than ours. Because if it's more expensive than ours, then we need to insert ours right there and push that one back to the end. So what that would look like is we need to, if the current one, so the current pizza price, so we're iterating over this, and we want the price, which is in the first item, if that is greater than our new topping price. And if that is the case, let's keep this. But instead of I, we're gonna do, or instead of 4, we're gonna do I, which means the index that we're currently at. And then we're gonna insert this new topping. And then because we're in our array, we have done what we needed, so we're just gonna break out at this point. So let's see, we have popped, and let's clean this up a little. So right now, it used to be 1, 2, 2, 2, 3, 6. And after our little algorithm, it is 1, 2, 2, 2, 2.5, 3, 6. So it looks like it correctly put it in the right spot. And this is great because if ever we change the price, let's say sausage is on sale or something like that, and so we change sausage to 1, then all of a sudden sausage is way here at the beginning with cheese, and the peppers is in the right place closer to the end now. And I think that is about it. So the last one I wanted to look at is, I know they said we didn't have to create this using the existing, the pizza and prices using the existing variables, but I think it might be fun to use the existing variables. So what would that look like? So we actually have an example of iterating over an array. So why don't we take this example? So what we are going to do is, instead of hard coding this new array here, we are going to use our existing variables. So we have toppings and prices. Those are our existing variables. Let me comment this out. And I'm actually going to go ahead and comment this out because this is our original hard-coded. So what we can do is, well, we're not iterating over that for certain. So what we need to do is iterate over the num pizzas. And actually we already have a length here. So, and what we're going to do is build this new array by hand using the existing variables. So how we talked about how you can add to an array, but we used insert down here. But the other variable, or the other method you should be aware of, is the append. So if we append a new array, and the first one is going to be the prices at this index. So we're essentially iterating over both the prices and the toppings? Yeah, toppings at the same time. And we're kind of combining the two into one. Let's go ahead and see if that gave us what we want. Perfect. So we haven't sorted it yet because that's right underneath where we are, but you can see here the 2 pepperoni, 6 pineapple, 1 cheese. So this is an even more kind of flexible way, because if ever we change the toppings or the prices, we are not, we don't have to change it in 2 different places. We are reusing those variables and just kind of reshaping the arrays as we need them. Now, we can actually do a couple better. We could actually do a comprehension. So this is the kind of formal array-based version, but what if we wanted to fit this into an even more compact version? Well, what if we create this item for I in range? I think that is the right syntax. Let's try that out. There you go. So you can see it's kind of like a for loop, but it's a for loop that's inside an array. So it like creates the array while iterating at the same time. So if you're not unfamiliar, or if you're unfamiliar with comprehensions, definitely look up the syntax. But essentially the first item is the element for each item in the array. And then this is how you get that element. So I for I, and it is in something. So we create a range over, which basically creates an iterable for numbers 0 through the length of, well, in this case, num pizzas. So this is a different way to be able to kind of combine those 2 lists into a single multidimensional array. But you know what? That is not the only way of doing it. There's actually an even more fast and simple way if you know the Python syntax. So there is a method called zip, and zip can take multiple iterables. So lists are iterables. So let's do prices and toppings. So this will zip these 2 lists together. Now, this is actually going to error out, because this is the one thing. You can create code that is very concise if you know the language and the syntax and the methods and variables, but you also have to understand what's happening here. So with zip, it takes in what are called iterators, but it also outputs an iterator. And an iterator is kind of like an object that you can iterate over, but it's not a list in and of itself. So what you need to do, if this needs to be a list, is you need to actually construct a list using that iterator. So we're back at square one, where we have this multi-dimensional array with the prices and the toppings. So this is a very concise way of doing that kind of for loop or the comprehension. And we no longer need to hard code in. So yeah, I think that is all the kind of improvements that I see. Let's leave it at that. Let me uncomment some of these, and this will be in my projects list. So if ever I want to kind of reference these in the future, I can. Thanks for joining. Thanks for following along. Hopefully you're feeling a little more confident in your Python experience. If you're looking for any more practice, hands-on experience, projects, courses, or even career paths, head over to Codecademy. I'll leave a link in the description. As always, if you like the video, go ahead and hit the like or subscribe. And if you want to be notified next time we release a video, go ahead and hit the notification icon. Happy coding!